Bismillah ar-Rahman ar-Rahim. Good evening, my friend. Today, we will speak about the minimum ventilation in cold climate and LPV maybe, and also about the comfort zone at the birth and humidity in summer time, and ventilation during hot weather. Doctor,
Yes, please.
you are manager on this webinar, and please give us a point about the start some issue.
Right. First, I introduce myself and my company. I am IMRAN QAYYUM. I am from HICO-Poultry Houses consultant. I am the CEO of my company and Doctor of Ventilation Group of HICO. And we are working to promoting the poultry and livestock education, especially specific in the ventilation, because I am working from 2000 in this field. I got a lot of experience, exposure, and I visited a lot of countries because of this. And Alhamdulillah, now I feel that this is the time for feedback. So I start this work. I start the free consultancy groups. And when I started, I was alone at that time. But now in my group, the HICO group, the Doctor of Ventilation group, there is a lot of PhD doctors, a lot of farm managers, a lot of general managers, and a lot of university professors are in my group. And also a YouTube channel of HICO-Poultry Houses Consultant also we launched, and we promote the basic of the poultry ventilation, and the different also we promoted the livestock ventilation, and also after this now we started the brooding management, the layer brooding, the broiler brooding, and the breeder brooding management courses and ventilation courses from HICO Group. So thank you very much, Mr. Mahdi Biglary, and thank you for your invitation in Iran, and Assalamu alaikum from Pakistan, and thank you very much. You invite us, and yes, sir, please. First, you start on the questions, and I will be inshallah ta'ala here for your questions, sir.
Thank you, Doctor. Now, and my friends in this webinar, now we are part of HICO group, and
Yes.
Also this is good, fortunately for us, learning and share our experiences to other friends. Inshallah, occur good synergy in this webinar and other. In the first, I have some question in minimum ventilation, and I will ask you.
Yes,
Do you
please.
completely close inlet after fan off time?
Yes.
And
Actually, one I will add something, because this is a the answer is very lengthy. If uh, if you allow me, because in minimum ventilation is, you know, very, very critical ventilation in the poultry life. So we must take care a lot of things. And last night I already discussed with you that why we do the smoke test, why we did the leakage test, because we will set the curve, the low pressure curve, the low power curve, ventilation curve of the house. It depends, it's very house to house. Yes. And we will perform the smoke test and we will adjust the inlets. And last time I tell you that if you adopt the advanced delay technique of the inlets, then it will be a very beneficial for you. Because you know, the stocking density of the chicks is very small. So you have a very big place, big shed you have for the brooding. So in what is in advanced and delay techniques, there is 50% inlets are opening, 10 to 12, 20%, and after that, the remaining will be on. So for the negative pressure, why we do this? Why we do this? Because you know, when the chicks minimum air requirement is very small, what we do,
Yes.
we will bring the fresh air. The main thing is that, and we will care that the fresh and cold airs do not hit the chicks. That's why we maintain a pressure according to the house width. And this will be assumed in our smoke test. And at the time, you know, this is a very small time, the fan is on and off. Okay? When you have a chicks in brooding time, it's just in seconds. It's 20 second, 30 second, 25 second, it depends. But what we do, we install one variable fan in the minimum ventilation. Side wall fans is a variable speed fan. And we adjust the inlets. I tell you last time that it's 20 mm or 25 mm. It depends. So we adjust the inlets, and there is a, I will tell you one very unique thing, that the most of the controllers in Big Dutchman and Vipers, they have an option that the inlet should be open before the fan exertion. Now you keep my point. So we will,
Yes.
what we do, we will give the command of 10 seconds before the fan exertion. The inlets open before the fan exertion, before 10 seconds. So when the fan start, he create a pressure, and we also set the pressure 20, 22, 23, 24 Pascal. It depends on the width of the house. I already mentioned before. So at the time, the pressure, and when the eh, when the fan exertion is off, the fan is off, and the inlets are going to close. So this is the phenomena. But in the world, there's a lot of controllers. They have an option that without the fan exertion, you can open your inlet 5%, 10% after you select a cycle timer and you adjust it. Especially in winter, or in that areas where the outside temperature is very low, or there is a snow falling outside. So what this phenomena do, that it does not allow to deposit the snow on the inlets, and inlets are moving after 4 minutes, 3 minutes, 5 to 10%, and then close. So this is the main thing that is happening. Yes, please.
Thank you. And other things, and number two is that do you use timer cycle in LPV?
Why not? What is LPV? I will tell you the basic. What is the LPV? It's a low pressure. You definitely in our houses is 20, 22, 23, 25 Pascal. Yes, not more than 25 Pascal. You know, the maximum width of the house. Now we, last time, uh, we designed the 65 feet width house. So, and what the pressure we assume from the smoke test, it's 24 Pascal. So that's why it's called low pressure. And in winter ventilation, we also use low pressure, but in a tunnel ventilation, maybe it can increase 5 to 10 Pascal. It depends, because you know sometimes your curtains, your tunnel doors opening late, and this and that. So that is the reason I tell you. Yes, please.
And number three, how do you calculate LPV?
Oh, yes. Very interesting question. Yes. The first test I performed in Bangkok in 2007 by my boss, my teacher, Mr. Werner Grenman and Tommy from Scove. Yes,
Yes.
I mentioned Mr. Werner, yes, because he is my boss, he is my teacher, and really he is very best friend of mine, because I learned a lot, and many times I asked him and he will answer. He answered very briefly. That's why I learned a lot by Mr. Werner Grandman. Yes, and at the time, Mr. Werner is the in working as a chief in Asia region, and now he's in Big Dutchman. I think you know very well, Mr. Warren. So what is LPV? One thing I'll add you, that LPV curve, also we call is the curve. We will make a curve. There are 10 points. The different controllers have a LPV curve in for winter ventilation and side mode ventilation, and in tunnel ventilation you also need a LPV curve if you can maintain the pressure in tunnel. If you don't want to maintain the pressure in tunnel, you just switch it no, and then when your system shift into the tunnel, it will directly, the tunnel doors and the curtains will be open directly. But if you want a pressure in your tunnel, then you will be also make a 10 points for the tunnel ventilation. And in winter ventilation, you adjust the inlets, opening of the inlets and exertion of the fans. You keep my point? I think you keep my point.
Yes. And about the calculation, my purpose was about the difference between the traditional minimum ventilation and LPV. What is the advantage? I know low pressure and decrease or requirement to high pressure in minimum ventilation, solve it and other. But about the basically science in ventilation calculation, my question was, what is the differences between the physical calculation in shed in compared to the other minimum ventilation method? What is the differences? I know the low pressure, and we need to low pressure during the air intake in cold time, and other differences, please, if it's there, please say us about the other differences.
Would you like to please repeat your question, because there is some sound problem, that's why I not got your point. Will you please repeat?
Yes. In LPV, you said about the LPV, main benefit in LPV is the low pressure requirement in minimum ventilation during cold weather in outside. And if it's there, other benefit and advantage in LPV, please say us about it and compare to other minimum ventilation method.
Right, I keep your point. So what we do in the LPV, it depends on your controller. First, I tell you that if you have a LPV curve option in your controller, what we do, we make a calculations of the fan exertion, the input per minute. Okay.
Mm-hmm.
We will explore that how much inlet will be open and how much air is requirement from the initially, especially in the brooding. That's the first phase, because it cannot decrease. If you have a 30,000 bird, you can calculate the minimum air requirements. So it should be less than, I think, 10,000 CFM. What do you think? Yes. So what we do, we calculate that the inlet will be open with the exertion of fan, and I tell you that the best advantage of the LPV curve is that if your negative pressure is failed, if your negative pressure sensor is failed, but your system will be work according to the ventilation and according to the negative pressure, because the main thing is that the fan exertion, when the fan exertion is increased and the inlet opening is increased, but what is the main thing, that the pressure is the constant. We will start on 25 Pascal, and when your all side fans start to run, at the time your pressure is 25 Pascal. This is the main thing, that you keep my point. Yes. And if many times the pressure sensors are faulty, yes, and sometimes they're cable problem, sometimes they're plastic pipes problem, sometimes some insect went in the plastic. So the efficiency, we will, after the LPV curves, we just check the pressure sensor for the reference. Or pressure gauge, it depends on the manometer you install, or manometer gauge you install, it depends on that. So we calculate every exertion of fan from the start to end, from 0 to 100%, and also we calculate the inlet opening from 0 to 100%. But the main thing is that your pressure that we explore from our first step by the smoke test to check the air movement of the house. We check there the air movement of the house, and the air comes from the inlet and cross the mid of the shed and hit to the center of the house, and after it will drop. That we find in the smoke test. So this is our, from first point to last point, this pressure will be, we set it. You got my point?
And doctor,
Yes.
for example, we have the windy day. For example, today is the windy and wind coming inside the house, and dynamic pressure go to the house, and we have now the variable pressure in house, inside the house, and pressure sensor sense this differential and differences pressure, and adjust the fans RPM and fix and stabilize pressure in house. Is it correct?
Will you please repeat again?
We have in the windy days today,
Right.
and in the winter, hard winter,
Yes, yes,
wind coming from the outside to inside of house,
yes,
okay? And sensor sense differences pressure in
yes,
house,
yes, yes.
and decrease fans RPM, and stabilized pressure in house, and we have nice direction and equal distribution of the air intake from the inlet to inside the house. Is it correct or no?
Actually, still I not got your point. I understand that in the windy season, when the
Yes.
wind is blowing, and especially in winter, you told me that when the pressure is the difference between in the pressure sensor feel that it's a lot of wind and this and that, and then what to do, this is your answer question.
Yes. Yes, it is my question about the reflex of the controller to stabilize and keep stabilized pressure in house. For
So
example, we
yes, I understand. Yes, for example, you tell us example.
for example, we have 12 meters wide in in our house, and we adjust the 12 Pascal after or a smoke test and another things. We
Right,
reach
right,
to
right.
the 12 Pascal is the good for our minimum ventilation, okay, in LPV. And we adjust in our controller 12 Pascal. After coming wind and and pressure coming to the air to inside the house, and suddenly pressure increased, because this is the dynamic pressure, okay? And our sensor is the static pressure, make the differences between inside the house and outside the house.
I got your point. Okay, I got your point. So this is the advantage of LPV curve controllers. That's you are telling about the this problem, that because of the wind, the pressure sensing, and when the pressure is increased, it will close the inlets. Yes, it will close the inlet sometime. Yes, because So in LPV, when you made a LPV curve, then you have a no problem because your system is not controlled by the pressure. And normally you have an option, you can active the pressure control and your system switch over to the pressure sensor. And what the pressure sensor sense, because when there's a too much wind, there is a sensing difference. And what the controller will do, I tell you that it will that they open the inlet more. When the pressure increase, what the controller do, he will open the inlets. So it will disturb the uniformity of the house for the optimum temperature. You will not got the optimum temperature, the uniformity of the temperature in your house. So this your question, and this problem is the advantage of the LPV curve houses, because your system not depends on the negative pressure. Yes, also, I think I told you last time the placement of the sensor. I expect that you will ask me the question about the placement of the sensor, because this is related to that point. Yes, please. I think you satisfied with my answer.
Yes, it's a nice answer, but my question was about the uh, pressure sensor if you buy from the ESCO pressure option, pressure control option. Okay,
Have just
and you have your system working with the differential pressure inside and outside. Okay,
yes.
and if coming windy, a wind to outside, sensor sense the increasing pressure outside.
Okay, sir. I got your point.
And
I got your point.
I
I got your point.
one
I got your point. I
one
got
one
your
thing
point.
please, and sensor sense differences pressure between inside and outside. Okay,
Yes,
and
obviously, obviously.
feedback system send the feedback to the fans, inverter and fans, and decrease RPM of fan and stabilize pressure. Okay, and
Yes.
and this is in uh, this is in the mm, one wide range of the differences, or in the just in the minimum range of the differences between pressure. This is my question.
I got your point.
And accuracy. This is
Before you are finished the question, I got your point, because
yes.
I tell you that the lot of controllers have different options in the control. If your house is active on pressure control, there is a option of a delay time for this problem. There is a option of a delay time. You can make it. Yes, I what I do, I make it 1 minute or 1.5 minute or 2 minutes maximum. I put it 2 minutes delay, you know. So I will put it into the delay. And also the controllers have an option that you have a variable range. If yes, if you can set in your controllers, you have variable range that if your house is set on the 25 Pascal, you will allow them that 20 and 25 Pascal, or 25 and 30 Pascal. You will allow them, and it works on between of that. So it doesn't happen that if your pressure is decrease and increase, and also there is a delay time of the inlet opening delay times. So of the pressure sensing delay time is also there. So it will not disturb your uniformity of the house. This is my answer, sir.
Okay, it's I understand, and it's enough for me. And number 4, what is the best jet heater placement and sensor placement in longitudinal shed, longer shed?
Yes, longitudinal shed, yes.
More than 120 meter. 120 meter.
Last time, we discussed on this, that in Pakistan we are using the paracuri and different type of heaters, the diesel heaters, and direct and indirect heaters also. So that's why we used only one heater for one house. And that heater we placed outside of the house, mostly. But sometimes that is at the pad side of the house. When we place inside the house, that is more than 250 kilowatt, 270 kilowatt. So mostly we used one heaters. And I have experience of space raise heater. I already installed the American Space Ray heaters. Their length is 40 feet. And we will dispute the house from the front and rear, 20 feet from the front and 20 feet from the rear side of the house. We install this, and then we will be calculate the between the area of that side, and we will install that heaters. So their action is like this. It's like this. But you are telling about the other heaters. I tell you that according to your specification, you install the mostly 6 heaters in the house. So it will be like this, like U type. And the sensor should be placed from 6 to 7 feet away from the sensor. This is very important. Your heater sensor, because if you install the 6 heater in your shed, you must install the 6 temperature sensors in your house, and one is for outside temperature sensor. So mostly in floor houses where we use only one heater, we install the 3 temperature sensors. One is in the middle of the house, and the other are 20 or 30 feet away from the front and rear side of the house. And so the placement of the sensor is very important, because if you can install near to the heater, it will be close early, yes. So for the uniformity, for the average temperature, you must install more away from 5 to 6 feet away from the heater you install. And the height of the sensor should be 1 meter above. That is same like your last question problem of the windy area, because if you install 1 meter above the floor level of the temperature sensor, your system will not disturb, because it is also delay time, the sensing delay time, you know. Because if you install that one near to the bird level, and if the temperature is increased, their action will very fast. So if you decrease your controller function and action, you will put it on the 1 meter above from the house. All sensor, temperature sensor, humidity sensor, all sensor. So this is the answer, please.
And it's good. It was a strong answer. Thank you. And about the placement of the sensor between 2 jet heater. For example, I send you some drawing about our project. We have 2 jet heater, for example, in one house with this type. One of them send the heat air to the back, and another sent to the front.
Right.
Where is